Chapter 4, Section 9 is about isosceles and equilateral triangles, because those are kind of special. So by the end of this lesson, you should be able to prove theorems just about isosceles and equilateral triangles, and then apply those properties. So remember, an isosceles triangle has at least two congruent sides. The congruent sides are called legs, and the vertex angle is the angle formed by those legs. So in this picture, your vertex angle is this guy up here. The side opposite the vertex angle is called the base, and then you have base angles here and here. So we have a theorem just special for isosceles triangles, and it says if two sides of a triangle are congruent, then the angles opposite the sides are congruent. So these base angles down here have to be congruent if these sides are congruent. So it's kind of a special theorem, a special shortcut that we have. So let's prove that. I'm going to tell you that AB is congruent to AC, so the two legs of this isosceles triangle are congruent. And we need to prove that B and C are congruent. So basically we're proving that theorem. So we have our statements, we have our reasons, and then this theorem's kind of weird because it just draws that random line in there. So we're allowed to do that and call X the midpoint of BC. So draw X as midpoint of BC. And the reason we can do that is that every segment has a midpoint. And then after that weird one, what we're going to do is draw a line from A to X. So this dotted line in here, we're going to draw AX. And the reason we can do that is we have 2 points, we have A and we have X, and it makes a line. So every 2 points can form a line. So now that that weirdness is out of the way, what we've done is we've made two different triangles here. So the important thing is we made X the midpoint of BC. So that tells us that BX and XC have to be congruent. Definition of midpoint. And then we also know that AX is congruent to AX by the reflexive property of congruence. So now what we've done is proven that these two triangles, AXC and triangle AXB, are congruent by side, side, side. So now that we know those two triangles are congruent, we can use CPCTC to prove that any parts of those triangles are congruent. So then this angle here and this angle here have to be congruent. So angle B has to be congruent to angle C. So some proofs are a little weird. They draw some extra stuff in them, but we just turned that one triangle into two different triangles. And then based on side, side, side and CPCTC, we can prove that B has to be congruent to C. So here's another one. The converse also works. If you have two angles in a triangle that are congruent, that means that these sides have to be congruent as well. So let's do an example. We won't prove this one. So I'm going to go and tell you that these two sides are congruent. So that means that these two angles have to be congruent. And then I tell you that this angle up here is 22 degrees, and we need to find out how big F is. So we have to remember that all the angles in a triangle, angle E plus angle F plus angle D, have to add up to 180 degrees. And then we know angle E is 22 degrees. We don't know angle F and we don't know angle D. That's two unknowns. But we know that they have to be equal. They have to be the same because these two sides are the same. So if we don't know F, we can make it a letter. Let's make it X. D has to be the same letter because they both have to be the same value. And they have to add up to 180. And then this looks like an easy enough thing to solve. Got to get X by itself. So if we subtract 22 from both sides, we end up with 2X equals 158. And if we divide both sides by 2, we end up with 79. So that means anything we said X, so angle F and angle D, both have to be 79 degrees. And you can quickly double check this. If you add 79, 79, and 22, you should end up with 180. So now the next one is kind of an isosceles triangle that's turned on its side. So remember, you have your two sides here. Those are your legs. This is your vertex angle. And these are your base angles. Now the thing says that your base angles have to be equal. So we know that 3x has to be the same value as x plus 44. So if we solve this one, we get that x is 22. Now remember, this is asking for us to find the measure of angle G. So all we got to do is take that and plug it back in. And if you do 22 plus 44, we end up with a nice 66 degrees. So now we have equilateral triangles, and both of these make a corollary. And remember, a corollary is like a consequence of a theorem. So if we have theorems, we end up with corollaries just because. So the first one is about an equilateral triangle, and it says if a triangle is equilateral, then it has to be equal angular. So if all the sides are congruent, all the angles have to be congruent. And the corollary works the other way around. Its converse does. If all your angles are congruent, then all your sides have to be congruent. So anytime you hear equilateral, it's exactly the same thing as equal angular. You have equal sides, equal angles. They're all in the same triangle. So let's put that to work. Let's find the value of x. So I look at this triangle and I see these three even sides. That tells me it's equilateral. And that means it's equal angular. And because we know all the angles have to add up to 180 degrees, if it's equal angular, each angle has to be 60 degrees. So that makes this problem really easy. I know that this angle right here, this 2x plus 32, has to be equal to 60. And then all I got to do is subtract 32 from both sides and divide both sides by 2. And we get x is 14. And remember, we're not trying to find the degrees because we already know it should add up to 60. We're just trying to find out what value of x would make that true. So now the next one, I see that all three of these angles are congruent. So that means they're equal angular, which means that it has to be equilateral, which means every side is the same. So we get 5y minus 6 equals 4y plus 12, and then we got to get y by itself. So if we subtract 4y from both sides, and then we'll have to add 6 to both sides, we end up with y being 18. Remember, again, we're not asked to find what the side lengths are, just the value of y. So you should be able to prove theorems about the isosceles and equilateral triangles, and then apply those properties to solve problems like we just did. And most of what we're going to practice tomorrow is the applying properties thing. You'll do a couple proofs. So write down any questions you have, and we can go over them in class. Have a good night.